Our client, one of the world's largest multinational corporations, was facing a growing challenge. Millions of documents, PDFs, emails, HTML reports, were scattered across systems with no unified structure. Searches were slow, results lacked relevance, and context was often lost, leading to delayed decisions and missed opportunities. To address these challenges, we engineered a retrieval-augmented generation system capable of ingesting documents, understanding context, retrieving relevant information, and generating accurate responses in real time. We started with Docling ingestion, bringing in structured and unstructured content from multiple sources. These documents were then passed through a transformation and segmentation phase, where content was cleaned, split, and organized into meaningful chunks. Next came the embedding generation. Here, each chunk was converted into high-dimensional vector representations or embeddings that captured the semantic core of the content. Finally, these embeddings were indexed in Qdrant, a powerful vector database optimized for fast and intelligent similarity-based retrieval. Once the knowledge base was ready, the real-time question-answering process kicked in. It begins when a user submits a question. The system immediately performs the retrieve Qdrant step, scanning the indexed embeddings for the most relevant document chunks. These results are passed through a grade relevance step, evaluating how contextually appropriate each chunk is for the user's question. At this stage, the system checks whether the retrieved documents are relevant to the question. If they are, the system proceeds to LLM generation, where a large language model uses the retrieved context to draft a response. On the other hand, if the retrieved documents are not relevant, the system skips generation entirely. It directly enters the rewrite question stage, rephrasing the original query to improve clarity and intent, and then restarts the retrieval process. Before delivering the response, the system performs a hallucination check to ensure that every part of the answer is grounded in the retrieved documents. If hallucinations are detected, the system loops back to LLM generation, prompting it to regenerate a more accurate response using the same context. If no hallucinations are found, the system evaluates whether the response actually addresses the user's question. If yes, it proceeds to the final answer and delivers it to the user. If no, it triggers a rewrite question to refine the input and rerun the loop. This loop continues autonomously and intelligently, cycling between LLM generation, hallucination checks, and question rewriting when needed, until a high-quality, verified, and contextually accurate final answer is delivered. The results were transformational: 80% increase in relevant document retrieval, 70% faster average retrieval times, 40% boost in employee productivity, 30% reduction in operational search costs, 50% increase in enterprise knowledge base utilization. These weren't just metrics. They marked real gains in decision speed, efficiency, and data accessibility. Powered by semantic embeddings, contextual reranking, and LLM-driven synthesis within a scalable DAG-based engine, the system transforms unstructured data into actionable intelligence. Fast, accurate, scalable. To explore this solution and other advanced AI workflows, write to us at business@rudderanalytics.com.